Okay, I'm volunteer at this Pumphouse Museum. This is the picture of the front of the museum. This is Lake Ontario back in through here. Anyway, there's three actually train layouts in there. There's an N scale, an HO scale, which is actually the original Friendly Giant layout on the CBC show. And it also has an O scale layout in here. The O scale is all hand done, and it's 1,500 feet of track and so on. But anyway, so I've been asked to using the Arduinos and why. And so this started off well 3 years ago. We did a little gondola. I want to show some pictures here. They're hard to see. Over here, you see them, my mouse. There's a head end of the unit, and there's two cable cars in here. And on this bottom right picture here, there's the far end of it as well. So about 15 feet of cable or rope or whatever going along through here. And we put that in originally for a Christmas train show for the kids, and we left it going. The problem was, it was brand new from a distributor in Peterborough, and it did not work from day one. And they would not honor the warranty, and nor would the manufacturer in Germany. So I ended up taking the head end apart and proved that the motor was working fine, but it was a control circuit board that was defective, and I couldn't determine what was wrong. So what I did is I used an Arduino to run the gondola back and forth. And there's a closer picture of the head end unit. And I can't see right here, on top of that in a second, there's infrared detectors. And the front pieces of the gondola cars up in here have reflecting tape on there. So that reflects the infrared back to itself. So what I did, built a dual power supply. One of them for the gondola motor. Actually, the motor uses 6 volts, but you lose a volt through this motor controller. So I did this for 7 volts and a 5 volt for the Arduino. This is Arduino unit here, and it's an Arduino Mini. You can do it in 3 volts, and you do them as a 5 volt. And I buy the 5 volt ones. And with these minis, you can buy them with the pins already soldered in place, or you can buy them a little cheaper, and you have to solder the pins in yourself. This unit, because Arduino is good for doing LEDs and stuff, does not have enough power to actually move the motor. So you have to go through one of these motor controllers. I believe they call this an H-bridge as well. So on their example here, there's a 7 volt supply from my dual power supply, and there's an output to the motor, to the gondola motor. And the Arduino is used to say when to go forward, when to go reverse, and so on, just by these pins. This is what the infrared detectors like. This particular one has 4 on there. I only use them 2. And the one transmits a beam out and then reflects it back from the gondola car and receives that, and then on the signal to a pin over here, which we attach to one of these pins here. So that's the size of this thing. This is only about 2 inches long, 1 inch wide type of thing. There's the H bridge, and there's a looking for the infrared detector over here. And so I'm not going to go through the coding, but the coding on the Arduinos, they're really sensitive to, for example, these curly brackets, for example. They have to be in the right place, and so on and so on. But and pay attention for your commas and semicolons and equals signs and stuff like that. What you do here with these little 2 double slanted things here, it's good. What for the our program of the Arduino ignores this. This is just for your use to find out what you're doing with it and why. So you can see that here. And when I'm doing the pins, what they're going to pins are going to be inputs or outputs and so on, and through here you can use the double slash here to say what the pins are going to be for, and why. So that helps you through the through the steps you go through. So the idea is that this thing will start the motor, and then when I'm going back here, when the gondola car reflects an infrared detector, it says to stop, waits for a couple of seconds, and then reverse direction, and then it just goes back and forth. So these two cars go back and forth all the time. So the kids like that. That was the main use for the Arduinos in there. Then we want to do a little accident scene. And for example, the tow truck has two flashing lights on it. This fire truck has one, and the police car has one. But I want to have a different flash rate on these flashing, because you don't want them all coming on and off flashing the exact same way. So the Arduino did that one really nicely. Another one for here for the crossing the flashers. There's also the oil train here. The infrared detectors back here. There's it on there. I got one on the other end of this thing. So this chain goes back and forth. That's all it does. And when the infrared detectors here bounce off here, the tank car, it will stop this, wait for 3 seconds, and then start up again and go in the reverse direction. For this engine be able to do the reflection of the infrared, I had to paint the grill work in here like a silver color to make sure it reflects okay. So those are the examples we're using at the museum right now. So that's it for me. Any questions?
That was great. Thank you.
Okay.
Any questions in the room? I do not see questions.
Okay.
Oh, just a second. There is a. He said, "Did you get the drawbridge on the castle to go up and down?"
Oh, geez, I forgot that. Hang on 1 second. I forgot I had that one too. Hang on. That's this one here. Come on here. Oh, I forgot about that. So we on a push button, the music, I have music starting for the Friendly Giant theme song. The drawbridge does come down, the doors open up, and then the interior is detailed. That waits 3 seconds or 4 seconds, I think it is. Then the doors close up, the drawbridge goes back up again, and the music stops. So this is the power supply I built for that. And these are all the Arduino. These are full-sized Arduinos in here. Arduino Uni, and there's another. You can put these. You can actually stack a bunch of boards. Different reasons for this. And there's the MP3 player here with a little chip up in here, and regular voltage regulators and relays and so on and so on. And that's for all the sensors go into these little pins in here, like when the doors, the micro switches for the doors when they are open, and when they are closed, and same with the drawbridge going up and down and so on, and when to start the music, when to stop. Sorry about that, I forgot about that one.